our next topic of discussion is equation of motion for uniform acceleration. Equations of motion. So now we are considering constant acceleration. Constant acceleration means its magnitude and direction both are constant. So what happens if initial velocity is 0? Acceleration is constant, initial velocity is 0, and suppose the value of constant acceleration is a. So what happens? What is acceleration? So acceleration will change velocity. If acceleration is along velocity, so it will increase the velocity. If acceleration is opposite to velocity, it will decrease the velocity. If initial velocity is 0, then acceleration is constant right side, so the particle will start moving right side. If initial uh, velocity is 0 and constant acceleration is left side, so the particle will start moving left side with increasing speed. So how to find velocity v and displacement s after time t, after time t? How to find velocity and displacement? We know that acceleration will change velocity. So if initial velocity is 0 and the acceleration is right side, so velocity will increase and the particle will move right side. Velocity will keep on increasing, so it is changing its position, so it is covering displacement and distance. So acceleration is constant, and we know that dv by dt is equal to a. So dv is equal to a dt, and integration of dv will be equal to integration of a dt, and we have a constant acceleration. So it will come out of the integration, and it is integration of dt. Now when time is 0, velocity is 0. I am assuming, let. So when time is 0, velocity is 0, and when time is t, the velocity is v. So the integration of dv will be delta v, and delta v will be from 0 to v, it will be v minus 0. So it is v, and on the right hand side, this is a delta t, which is acceleration into, which is constant acceleration into final time, which is t, minus initial time, which is 0. So this is a t. So t is nothing but time duration. Suppose we are observing from 0 to 2 seconds, so t will be 2 seconds. If we are observing time from 1 to 2 seconds, so t will be 1 second. It is a duration because initial time I am assuming 0, so final time is t, then time duration will be t minus 0, which is t. So 0 to 2 seconds t will be 2, 1 to 2 seconds t will be 1, 1 to 4 seconds will be t will be 3. So here t is a time duration, total time taken. So we have the relation now, we call it first equation of motion also. So left hand side we are getting v minus 0, which is v, and right hand side we are getting at. So v is equal to u plus at. So this is the velocity after t second when particle start from rest. Particle start from rest. The best example we have is motion under gravity. I have this object with me. So this is the object. Right now the velocity is 0. And we know that the gravity is pulling every object downward. So the force is downward, acceleration is downward. So acceleration due to gravity is downward. So when I release it, when I release it, it is falling downward. So the displacement is downward and velocity is also downward. Velocity is downward because acceleration is downward. So when acceleration is downward, the velocity is downward. It will increase downward. So let's take very basic question related to this formula or this equation. Now we have V is equal to AT when initially a particle is at rest. So find velocity after 2 seconds if constant acceleration is 2 meter per second square. So answer will be V is equal to AT, which is 2 into 2, so that is 4 meter per second. If the acceleration is negative, find velocity after 2 seconds if constant acceleration is 2 meter per second square leftward. So leftward means acceleration is negative. So we will write V is equal to AT. So this is minus 2 into T, which is 2. So minus 4 meter per second. Understand these two questions. If initial velocity is 0, let's say this particle I am talking about, initial velocity is 0, acceleration is rightward. So velocity will increase rightward, velocity will increase rightward. It will speed up rightward. And now the second question, this is the initial velocity which is 0. Now the acceleration is leftward. So initial velocity is 0. So it will move left side with increasing speed. It will go on moving right, left side with increasing speed. So velocity will be negative. What if initial velocity is not 0? Initially velocity is not 0. So we have to assume it. So let us suppose it is u. Initial velocity is u. This initial velocity can be rightward, can be leftward. If it is rightward, then u is positive. If leftward, so u is negative. So now our integration process will be dv by dt is equal to a. Now a is constant. We are doing constant acceleration. So dv is equal to a dt. Now integrate. So integration of dv is equal to integration of a dt. When time is 0, the velocity is u, and after time t, the velocity is v. So integration of dv is delta v, or we can also write v, limits u to v. Initial value is u, final value is v. And right side a is constant, so it will come out. So it will be a integration of dt with limits 0 to t. So it will become a into t, now limits 0 to t. So this is a into t minus 0. So left hand side we have v minus u, and right hand side we have at. So we have v is equal to u plus at. So this is the velocity after time t seconds, and this is also known as first equation of motion. First equation of motion. First equation of motion, but acceleration is constant. We have to remember it very clearly. It is uniform acceleration. Uniform acceleration means acceleration is constant, and in laws of motion we will study that the net force is equal to mass into acceleration. So when the net force is constant, the acceleration is constant. Let's do some questions related to v is equal to u plus at. Let's understand these questions directly using diagrams. Suppose initially at t is equal to 0, the car has velocity of 2 meter per second and acceleration of 3 meter per second square, constant acceleration. So how to find velocity after 3 seconds? What is the velocity? What is the velocity after 3 seconds? So as you know, the initial velocity is right side. Acceleration is also right side. So the velocity will increase. Velocity will increase continuously. So at 3 seconds, the velocity will be more than 2. This velocity will be more than 2 meter per second, because initial is 2 meter per second, acceleration is right side. Acceleration means it will increase the velocity here in this example. So velocity will keep on increasing. So what is the meaning of this? Let's understand using another diagram. Suppose at t is equal to 0, the velocity is 2 meter per second. Then acceleration is 3 meter per second square, means after every 1 second velocity will increase by 3 meter per second, because 3 meter per second means 3 meter per second square means 3 meter per second per second. Every second the velocity will increase by 3. So initially means t is equal to 0. What is the velocity? 2. So next 1 second the velocity will increase by 3. So t is equal to 0, the velocity is 2 meter per second. So now we can say at 1 second the velocity will be 2 plus 3, so that is 5 meter per second. At 2 second, now from 1 to 2 second the velocity will again increase by 3. So velocity will become 5 plus 3, that is 8 meter per second. And now coming 3 second. So at 3 second the velocity will again, it will increase by 3 meter per second. So velocity will become 8 plus 3, that is 11 meter per second. 11 meter per second. So this is how acceleration works. Every second the velocity will increase by 3 meter per second. So velocity will keep on increasing. But every time we don't have to draw these type of diagrams. This is only for understanding purpose. So we will use a direct formula. We have, when acceleration is constant, we will use v is equal to u plus at. So at 3 second the velocity will be u, which is at 0 second 2 plus a is 3, and time duration is a total 3 seconds. So that will be equal to 2 plus 9, that is 11 meter per second. So in 1 second, the after 1 second the velocity will be 2 plus 3 into 1. After 2 seconds the velocity will be 2 plus 3 into 2, and after 3 seconds the velocity will be 2 plus 3 into 3. So this is just for understanding, better understanding. We have drawn this type of diagram also. Okay, let's take next example in which the initial velocity is left side. At t is equal to 0, the velocity is leftward, suppose 3 meter per second. And the acceleration is right side. Acceleration is equal to 2 meter per second square. Acceleration is positive, so this is positive acceleration. And this is negative velocity, because leftward means negative. Leftward means negative. What happens when acceleration is opposite to velocity? What happens? This is known as retardation, because acceleration is opposite to velocity. When acceleration vector is opposite to velocity vector, maybe some students remember retardation as negative acceleration, so that is wrong. Retardation can be positive acceleration. The retardation meaning is acceleration is opposite to velocity. If acceleration is rightward, so velocity is leftward. If velocity is rightward, so acceleration is leftward. So in this example, velocity is leftward, acceleration is rightward. So here, let's find out what is the velocity after 1 second, what is the velocity after 2 seconds. So the meaning of this acceleration 2 meter per second square is 2 meter per second means after every 1 second add 2 meter per second to velocity. So what is the velocity at time t is equal to 0? It is -3. So I'm drawing the same diagram once again for better understanding. So we have t is equal to 0. The velocity is left side 3 meter per second. So I am writing -3 because it is left side. After 1 second, the velocity will be, after 1 second, velocity will be 3, -3 plus 2, that is -1. So t is equal to 1. The particle is shifting left side. So the time after 1 second, the velocity is leftward 1 meter per second. So -1 meter per second. Then after 2 second, what is the velocity? So after 1 second it is -1. So this is -1 plus 2, because after every 1 second the velocity will increase by 2, so it will become 1 meter per second. What is this? What is 1 meter per second? Now at 1 second the velocity is leftward, and at 2 second velocity is rightward. It means what? The particle velocity is decreasing, it will become 0, but permanently the velocity is not 0. It will reverse its direction, it will start moving right side. So we can also find when velocity is 0. So using the symmetry, we can say from 0 to 1, in 1 second the velocity will be +2, increase by +2. So between 1 to 1.5 second, it will increase by +1. So velocity will become 0 in next 0.5 second. And also we can use the formula v is equal to u plus at. If you use v is equal to u plus at, so we can put I want to find when v is equal to 0. So v is equal to 0 means u, which is minus 3, plus a, which is 2t. So that is 3 is equal to 2t and t is equal to 1.5 second. 3 by 2 means 1.5 second. So at 1.5 second the velocity is 0. So the particle has traveled leftward between 0 second and 1.5 second. After that, what? Can I say it is at rest permanently now? It depends on question. If question is saying acceleration is constant always, means the motion will continue. After 1.5 second also the motion will continue, but where it will go? So when velocity is 0, we have learned when velocity is 0, it will check where is the acceleration. If acceleration is right side positive, so the particle will move right side. If velocity is left side negative, so the particle will move left side. So now the velocity is 0 and acceleration is positive, so the car will start moving right side. So afterwards the velocity will be positive. The car will start moving right side. It will go on moving right side until the acceleration is acting. Acceleration is there. So we can use this formula v is equal to u plus at. Suppose we have to find what is the velocity after 5 seconds in this situation. So at 5 seconds, what is the velocity? So we will use this same formula. V is equal to u plus at, and we will put u is equal to minus 3, a is equal to 2, and time taken total is 5. So that is equal to minus 3 plus 10, that is 7 meter per second. 7 meter per second. So 7 meter per second rightward the velocity. So this is how velocity changes when acceleration is uniform.